Hey, welcome back. So, last time where we left, we had a very simple image of a rocket on the screen, kind of what you're seeing now. But by the end of this lesson, what we're going to achieve is the following: the ability to move the rocket around as I move my mouse. So you can see that the position of the rectangle is moving as I change the mouse, but so too are the positions of the triangles. So let's figure out how we're going to do that. So as always, there will be the starter code that you guys can follow along with. I'm going to make a fork of the code, so I have my own copy. You guys can do the same from the link in the description. And here is our code drawing one rectangle and three triangles. Now, the tricky part here, or the part that we're going to have to figure out, is the following. In that the rectangle, the position of the rectangle moves, right? It's not static. At the moment, our rectangle is always going to be at 200, 200, right? And no matter where I move my mouse, we're not going to get the movement we're wanting. So we need to get the rectangle to move in a particular way. But what we also then need is for the triangles to move along with it. As you can notice, the triangles are following the rectangle. How is that happening? We're going to introduce or go over a topic called variables, which you might have seen. And variables is going to enable us to do what we're looking to do here. So what we have here is we're saying rectangle at position 200, 200. I could make variables for that instead. So I can say let x is equal to 200 and let y is equal to 200. So I made two variables, x and y, and I'm storing the value of 200 inside of them. And now instead of putting 200, 200 here, I could put x and y. And if I click run, nothing's going to change, but it's all going to be the same because this x, when the computer gets here, it's going to work out what is this value of x. It's 200. The problem comes in if I change this. If I move my rectangle to the middle or somewhere else, I'm going to move my rectangle to position 300, 300. Notice that the rectangle moves nicely, but our triangles are completely wrong. They're still where the rectangle used to be. We need the triangles to follow the rectangle in a very similar way to what you saw with when I was moving my mouse. Another thing we could do is we could also change the width and the height of the rectangle. So even if we went back, say we went back to 200, 200, and if I changed my width to say 50 and my height to 100, then we get that, right? So the rectangle changed appropriately, but our triangles are still in the same place. We also need to get our triangles to move appropriately. And the way we do this is through algebra. It's through expressing the position or the coordinates of our triangle in terms of the position of our rectangle, in terms of position x and y. So let's find out how to do that. I'm going to bring this back to 100 to 200. And to do this, we're going to use our favorite friend, the whiteboard, in order to work this out. So as always, we have a x-axis that goes from the left to the right, and a y-axis that comes from top to bottom. These are not the best axes in the world. What can you do? So we have x and we have y. Now, we had a rectangle that's sitting somewhere over there. Let's move this rectangle just a little bit. Oh, no. That won't do it. Okay. So we have a little bit more space. So we know the way we've defined it before that our x and y coordinates over there is 200, 200. And then we managed to draw a triangle over there. Now what we've changed is instead of saying our x and y position is 200, 200, we're saying our x and y position is a variable x and a variable y. So this variable x could be 200, or it could be 50, or it could be 33, or it could be 1,007.2. That's what's useful about variables, is that it allows us to make them hold any number. And now what we need to do is define these coordinates of our triangle in terms of x and y. So let's go ahead and do that. Let's start with this one. This one's pretty simple. We know it's x and y. Okay, so our purple point is x and y. This point over here, we know our width over here is 100, as we've defined. So we're going from x and then we're going to go 100 to the right. So the point we end up at is x plus 100, and our y is staying the same. The final one, this one, at the top, we know we're going 50 units across. We're going half of our width. We're going 100 over 2, which is 50. And then we're going up whatever our height is, and we've defined it as 50. So our x is changing by 50, so we're saying x plus 50. And our y is changing by 50 as well, but our y is going to decrease because we're moving up. So we get y minus 50. So this is now the algebra which describes the positions of the triangle relative to the position of the rectangle. Let's put that into code and see what it looks like. So I'm going to say x, y, x plus 100, y, x plus 50, and y minus 50. We click run, we should see the exact same thing. Okay, now let's change our x. If we changed our x to 150 and our y to 150, so we move in the rectangle, the top triangle should stay where it is, which it does. Beautiful. Okay, so we've now defined the position of our triangle, the top triangle, in terms of x and y. But what happens if we want to change our width and height of our rectangle? Those are some additional variables as well. So if I say let width is equal to, let's say, 50, and let height is equal to 100, and I use width and height as the variables. I get the following, that the triangle is not sitting exactly where it is. We need to change the width of our triangle based on what we've changed our rectangle. So let's jump back into the whiteboard, see how we can do that. These numbers, so the 100, the 50, the 50, those numbers we got based off of the width and height of our triangle and rectangle. We got x plus 100 to get to this point because we know that the width is 100. If our width was 50, then this would be x plus 50. If our width was 73.2, then this would be x plus 73.2. So we could define this instead of we are going all the colors today, instead of as a number, as a constant, we can define it as another variable. And that variable that we've defined is width. So instead of saying x plus 100, we could say x plus width. So we know that this over here is width. Okay, and then this 50, we know it's half of width. So we can define that as w, our width, over 2. The height of a triangle we are defining as 50, but you can change that. So you can make a variable for that. So let's go ahead, update the code according to this. So now instead of saying x plus 100, I'm going to say x plus width. And instead of saying x plus 50, I'm going to say width over 2. Hit run, and now our triangle should work perfectly. So we can now move around our x and y around the screen, and we can change the width and height, and it'll work appropriately. So one triangle is just being drawn in front of another triangle while it looks funny. Let's do one of the corner triangles, because those are going to be a little bit more tricky. And then I'm going to leave you to do one of the other ones as a challenge question. So we want to draw, let's go in blue. We want to draw this triangle. And now the key thing that we want to do is we want to define these coordinates in terms of x, y, width, and height. Because that's going to allow us to change these variables and keep the shape consistent. So let's try it. We know that this position, or this line over here, all of them are the same for our x coordinate. So our x coordinate for these 2 points will be the same. They're going to be whatever our x is. This one is going to be based on how wide we make the triangle. So we've said before we're going to make the triangle 50. So this is going to be 50 to the left of x. We also said before that the height of this triangle is 80. So those give us the dimensions. Now let's work out what those coordinates are. Let's do one at a time. Let's do this point over here. Put it in orange. Bottom left corner of the rectangle. So we know that its x position is going to be x, right? It's in line with the top left corner, and the top left corner is defined as x. Our y position is going to be based off of the height, right? We know the height of our rectangle based on where we start, which is y, plus our height, because we're going down. So it's y plus height. That gives us that position. If we're wanting the position above it, it's the same for our x. Ooh, we jumped all the way down. It's the same for our x. However, we go from this point, which we know is y plus height, and we go 80 up. So it means we have to be y plus height minus 80. Finally, we're looking at this point over here. Last color, we'll go in green, a darker green. So we know the y is aligned with this point, right? Our y doesn't change from our orange point to our green point. So this y over here is going to be the same. It's not going to change. So what that then looks like, our x, we're going from x over here, and we're going 50 to the left. So it means we're going x minus 50. And our y is staying on that line, which is y plus height. So we have the coordinates of all of it. Let's put it into code and see what that looks like. So we're going to have x minus 50 for the 1 point. Okay, no, I'll go from the top. I'm doing it in a different order. We'll say x, y plus height, right? So we're looking at this point right over there, bottom left corner of the rectangle. So it's x, y plus height. The next coordinate, x, a little bit above it. So like the one corner of the triangle that's still on the body of the rocket. And our y is going y plus height. And then we're moving up by 80, so minus 80. And then finally we have x minus 50 and y plus height. Let's move our y, let's move this around somewhere. Let's go to position 350 and let's see if this works. And there we go. So this triangle over here is sticking to this. And I can change my width and height now. If I change my width to 100, if I change my height to 150, the triangle should remain in the place we want it to. Perfect. I'm going to pause here. I'm going to give you a shot to try and do it for the other triangle.
One eternity later.
All right. So this one is a little bit more tricky than the other one, simply because you just have to take into account the width of the rectangle. So our two x coordinates change by x plus width. And then the last point all the way on the end is x plus width plus the width of the triangle, 50. And now we have a beautiful rocket, which is dynamic, meaning that we can change all of these variables, can move them around, and it's going to stay together. The last puzzle piece remaining is how do we get this effect of it following our mouse? How is that happening? And it's actually really simple. I'm going to quickly comment out this code to show you something. We have access to a special variable in P5 called mousex and mousey. So I can use the text command, which prints text to the screen, and I could get the variable mousex, and I can put it at position 200, 200. Similarly, I could get text, and I can say mousey, and I could put that at position 200, 300. If I hit run now, oh, we can't see much because we have a black background. I'm going to change this to a white background. We can see we have these two numbers over here. So these numbers are printing out the value of mousex and mousey. And you'll notice as I move up and down, the bottom one changes a lot. As I move left and right, the top one changes a lot, because the top one is our mouse X position, and the bottom one is our mouse Y position. So I go all the way to the right corner over here, I should get 600, 600. If I can find it perfectly. There it is, yes. And if I go to the top left corner, I'll get 0, 0. So that shows you how we can use these variables. So now I'm going to quickly pause again and try and see if you guys can figure out what do you need to do in order to get the rocket to follow your mouse position. Okay, so I hope you gave it a shot. And it is as simple as saying the following, of just saying letting our X equal to mouse X and letting our Y equal mouse Y. So these are global variables that's defined by P5.js. So they've created these variables somewhere else in the code. And now we're saying, okay, make this X variable, which is defining the top left corner of our rectangle, equal to mouse X, and our Y variable equal to mouse Y. And then we've defined all of these triangles and all of our other shapes in terms of the variables which make up the rectangle. So now when I hit run, as I move this around, all of the shapes stick together. Perfect. So that's the end of this one, where we've gone over kind of variables and algebra. In the next one, we're going to be looking at logical operators, colors, and we're getting it closer and closer to finishing the project. I'll see you guys then.